Welcome to the new session of Sikshana Taranga, a program for grade 10 students to help prepare them for board exams. We'll be discussing today the very first chapter. The chemical reactions and equations. To be very specific, balancing of chemical equations are going to be dealt. So let's see what is the weightage of chemistry altogether in your science exam question paper. The subject weightage and the important tips. The subject chemistry is going to be well covered for 25 marks under the theme called as materials in daily life. And among this 25 marks that you are able to see, let's understand what many questions can be asked in different manner in terms of objective weightage. You will be getting 20% in terms of remembering aspect of Bloom's taxonomy. Any question paper is generally set based on Bloom's taxonomy. Next, we have 40% covered up for understanding aspects. 20% covered for application skills. The remaining 20% is focusing on the drawing skill as well as the higher order thinking skills. So altogether, the marks is going to be for 80 marks. Out of 80, your chemistry is just going to be for only 25 marks. So this 25 marks we are going to focus in the forthcoming days so that you can score centum. Now, there could be questions asked as multiple choice questions. They can ask you 1 mark question alone, just in one word. They can ask you 2 mark questions, which is going to be very much short in answering. They can ask you long answers for 3 mark questions, and for 4 marks again a long answer, and then finally we have 5 mark questions which comes as detailed answers. Now the total marks, you can all see, it is 80. Now the topic which we are going to cover today is balancing of chemical equations. Generally, any exam if you take up, nearly 4 to 5 marks is covered for the first chapter, chemical reactions and equations. 4 to 5 marks. Now, in balancing of chemical reactions, we generally have different types of equations. Some of them are called self-balanced equations, whereas some of them are called skeletal equations, whereas the next variety of equations are called as balanced equations. Today, we will try to understand self-balanced equation, skeletal equation, and balanced equations. Now, what is a chemical reaction? Any chemical change any chemical change which results in the formation of new products is only called as chemical reaction. It could be a change in the color of the solution. It could be the formation of a precipitate at the bottom of the test tube. It could be evolution of sound. It could be even evolution of heat energy. All these are different indications of a chemical change. So whenever we have a chemical change happening, you have to understand they are all irreversible changes. They are all irreversible changes because it is happening in one particular direction. Now, what is chemical equation? Short scientific representation. Short scientific representation of a chemical reaction. Of a chemical reaction is only defined as chemical equation. Generally, chemical equations, we can write it as word equation. We can write it as word equation. In short, you write it as WE, word equation. But sometimes in the board exams, you can see the chemical formula equations given. Chemical formula equation. That means this chemical formula equation, you can write it as CFE. So in the board exams, some of the equations you may have it as word equations. Sometimes they will give you chemical formula equation and they will ask to balance. Now, let's see. This is a wonderful compound, water, which is very, very essential for the survival of living organisms in this planet Earth. How is this water formed? Water is formed by the chemical reaction of hydrogen and oxygen. That means water is consisting two elements. One element is hydrogen and the other element is oxygen. So now, how to represent this in a chemical equation format? Chemical reaction is going to be written in terms of the word equation. Later, the chemical equation has to be written in chemical formula equation. So, hydrogen plus oxygen gives water. Hydrogen plus oxygen gives water. This is said to be what is known as the word equation, WE. Now, you have to write this in chemical formula equation. So let me write the chemical formula equation CFE as hydrogen, which is represented by H2, the molecular formula. It is made to react with, so plus sign is always indicated in a chemical reaction. Oxygen is given by the molecular formula O2. Hydrogen plus oxygen gives, you have to denote it by an one-sided arrow mark. It gives water. Now water is referred as the product. Now both these hydrogen and oxygen, they are called as reactants. Whereas what is formed after the chemical reaction between hydrogen and oxygen is referred as the product. So water becomes what is the product in this particular chemical reaction. Now this arrow mark tells the direction of the chemical reaction whereby the reactants are getting converted into products. These ripples of water is definitely nourishing our lives every day. Now, coming to the most important aspect of balancing chemical reactions. Now, hydrogen plus oxygen gives water. This equation is skeletal equation. You have to balance this equation. So, once I say I'm going to balance the equation, I have to follow a law. What is that law? That law is called as law of conservation of mass. Now, law of conservation of mass was given by the great scientist called Lavoisier. According to Anthony Lavoisier, total mass of the reactants in a chemical reaction is always equal to the total mass of the products. In other words, you can even state as mass can neither be created nor be destroyed in a chemical reaction. Now, the very meaning of this law of conservation of mass makes everyone to understand that the number of atoms on the reactant side should be always equalized with the number of atoms of the elements which are present on the product side, probably which is existing in the compound form. So very quickly, let me just balance this equation. H2 plus O2 gives H2O. Now let me balance. Hydrogen, how many number of atoms are there on the reactant side? It is 2. Well, on the product side, it is again 2. So it is balanced. Oxygen, here it is 2. But here it is only 1. So how to equalize this number? I will write LHS and RHS. This denotes left hand side, right hand side. Now I have to write down the elements which are there in the particular equation. Now there is hydrogen, there is oxygen. Now on the left hand side I am having 2 atoms. Here also it is 2. That means it is equal. Number of atoms of hydrogen are equal on both the sides of the reaction. Now oxygen, on the left hand side it is 2. But on the product side it is just 1. That means it is not equal to. Now what are we supposed to do, you know? We have to make this oxygen equal. So what we will do is, we will make this equal. That means I have to multiply this by 2. If I multiply by 2 over here, this becomes equal. So this number 2 has to be written over here. That means I will just introduce the number 2. So this equation, hydrogen becomes now unbalanced because you have introduced here 2. So 2 into 2 becomes 4 here. So now this 2 into 2 which you have introduced has to become equal on the reactant side. That means I have to write on this side, on the left hand side, I have to write the number 2. That means this equation 2H2 plus O2 gives 2H2O is only referred as balanced equation. Now quickly check the number of atoms, are they balanced or not? Now 2 into 2 becomes 4 for hydrogen atoms. Here it is 2 into 2, 4 hydrogen atoms. Oxygen is 2. Well, on the product side again it is 2. That means the equation is balanced equation. Now let's see the next equation. So all the equations which are getting balanced has to always obey this law, which is called as law of conservation of mass. Now another example is between 2 chemicals, one taken in the conical flask, which is acetic acid. So let me write the equation. Acetic acid is taken in the beaker. This is actually a conical flask. You can perform this activity even in a beaker. So this particular device which you are seeing here, it is in the conical flask. You are taking acetic acid in the conical flask, and the mouth of the conical flask is well covered by a balloon in which you are taking the next chemical, which is sodium bicarbonate. Baking soda is always referred chemically as sodium bicarbonate. So let me write now the equation: acetic acid plus sodium bicarbonate gives. Now the moment I place the conical flask containing the acetic acid taken in the conical flask and sodium bicarbonate inside the balloon and fixing the balloon over the mouth of the conical flask, I should observe what is the change that I am able to see in the digital balance. That will be the total mass of the reactants. Now, once the conical flask is placed in the digital balance, the reaction will start taking place between acetic acid and sodium bicarbonate. Then immediately the balloon will start getting blown up because the chemical reaction is resulting in the formation of the salt which is called as sodium acetate plus you have carbon dioxide plus water form. That means this equation is nothing but it is written in the form of word equation. Well, I want the same equation to be represented in another manner, which is called as chemical formula equation. So let me write here. Acetic acid is given by the formula CH3COOH. This is made to react with sodium bicarbonate NaHCO3. Then it results in the formation of CH3COONA plus I have carbon dioxide plus H2O. Now observe the total weight of the reactants. It is 243.68 gram. Once the conical flask is placed, immediately whatever powder, sodium bicarbonate powder is there in the balloon will fall into the conical flask and you will start seeing the reaction taking place, resulting in the balloon getting blown up. Why did the balloon get blow up? It is because of the carbon dioxide gas that has got filled up in the balloon. So again, this equation is a self-balanced equation. Now, how to balance a chemical reaction? We have to follow certain steps, one after the other. Step 1. Don't change the formulae. Whatever formula is given in the question, don't try to change. Next, you have to list out the number of atoms which are present. Next, you have to adopt hit and trial method for balancing the number of atoms of the reactant side being equal to the number of atoms on the product side. Finally, you have to do the checking whether all the atoms are equally balanced or not on either side of the reaction. For example, CH3COOH plus NaHCO3 gives CH3COONA plus CO2 plus H2O. Now, list the number of atoms. You have to see how many atoms are there. Carbon is there. Then you have hydrogen. Then you have oxygen. Then you have sodium. Now you have to write LHS and then RHS. Now reactant side is always referred as LHS, left hand side of the chemical reaction. Whereas the product side is always referred as RHS, which is called as right hand side. Now, how many atoms of carbon are there? 1, 1, 2, 3. That means, let me write here, carbon is 3. On the product side, how many are there? 1, 2, 3. So, on the reactant side it is 3. On the product side also the number of carbon atoms is 3. Next, hydrogen. 3 plus 1, 4 plus 1, 5. On the product side, 3 plus 2, it is 5. Now, oxygen, we have 2 plus 3, 5. Over here, you have 2 plus 2, 4 plus 1, 5. Sodium, here it is 1. Here on the product side also it is 1. That means all the number of atoms are equal. That means such a reaction is called as self-balanced equation. Self-balanced equation. But if the equation has not got balanced, you have to use hit and trial method. For example, we had seen H2 plus O2 gives H2O. We learnt balancing of the chemical equation by just adding here the number 2. 2H2 plus O2 gives 2H2O. This is what is known as the hit and trial method. So you can see the number of atoms, 2 into 2 becomes 4. Here also it becomes 2 into 2, 4. Oxygen is 2 here. Here it becomes 2. Final checking has to be done, which is nothing but seeing that all the number of atoms on the reactant side is equal to the number of atoms on the product side. Now, let's work out the first 1 mark practice question. Write the balanced equation for burning of coal. So, we have to know what is the symbolic representation of coal. So, first let us observe the phenomenon of burning of coal. These are the blocks of coal you are able to see, and it is getting burnt. Now, this particular equation has to be written. I will write the word equation: carbon plus oxygen gives carbon dioxide. This is the word equation. So let me write it as WE. Now, this equation has to be written in chemical formula equation. C plus O2 gives CO2. This is chemical formula equation. Now, number of atoms of carbon. Now, let me write here elements, and then left hand side, right hand side. Now, just to draw a small box. Element is carbon, the other one is oxygen. On the reactant side, how many atoms are there? It is 1. On the product side, it is 1. That means it is equal to. They are balanced. Now, oxygen here on the left hand side, it is 2. On the product side, it is 2. That means it is obeying the law of conservation of mass. So, it is always good to call this equation C plus O2 gives CO2 as a self-balanced equation. It is a self-balanced equation. Just one more question. Now, let's proceed to the next question. It is another one more question that is being asked for. Write the balanced equation for a chemical reaction taking place between zinc with dilute sulfuric acid. So first you should know what is the symbolic representation of zinc. Zinc is represented by Zn. It is made to react with dilute sulfuric acid. You have to write DIL and then write H2SO4. But when you are doing balancing of chemical equation, there is no necessity to specifically mention about this word DIL. You can write the equation as Zn plus H2SO4 gives. Now, what are the products formed? So now we will see what is the reaction happening. So let me show you. Zinc metal is taken in a particular test tube in which dilute sulfuric acid has been taken. The moment zinc comes in contact with this sulfuric acid, you can see gradually bubbles will start rising. You can see here the brisk effervescence of hydrogen gas getting liberated. That means the products formed from zinc reacting with dilute sulfuric acid is zinc sulfate. Zinc sulfate, the salt formed along with hydrogen gas that is liberated. Now, this particular equation has to be balanced in order to fetch you 1 mark. Now, the number of atoms, let me write here. Elements, zinc, hydrogen, sulfur, oxygen. Now, I will just draw a rough box. And then write left hand side and then right hand side. Now zinc is 1 on the reactant side. On the product side, zinc atoms are 1. So I will write 1. Hydrogen, it is 2 on the left hand side, on the reactant side. On the product side, it is again 2. Sulfur, it is 1. On the product side, again it is 1. Oxygen is 4 in number. Here on the product side, again it is 4. That means all the number of atoms are equal. That means this equation again becomes what is called as self-balanced equation. It is balanced by itself. It is called as self-balanced equation. Now coming to the next balancing of chemical reaction, iron, when it is made to react with steam, it results in the formation of what is called as Fe3O4 plus H2. Fe3O4 is called as mixed oxide of iron. It is also known as ferroferric oxide. Now, try to write all the elements and the products which is given in the equation, either in the elemental form or in the compound form if it is given. Put it in box for convenience sake. Next, make a tabular column, write the element first, then how many number of atoms of the elements are there on the reactant side, the left hand side. Then you make another column, number of atoms that are there on the product side. Now, iron, how many is here on the reactant side? You have 1. On the product side, you have 3. That means you have to equalize this. It is not equal. Next, hydrogen, it is 2 in number. But here it is again 2. That means hydrogen is balanced. Now, oxygen is how many atom on the reactant side? You have only 1. But on the product side, you have 4. So now, to quickly balance the equation in the exam, first priority is to be always given for the higher number of atoms which is seen in the equation. So you can see here, among iron, hydrogen and oxygen, the number 4 is more predominant. So you have to try balancing first oxygen. Then oxygen is in the combined form with what other element? Here it is hydrogen. So you start balancing first oxygen, then hydrogen, then finally you come to balancing of iron. Now, let's balance oxygen first. Now, oxygen on the reactant side was 4. On the product side also it was 4. Let me write the equation. Fe plus H2O gives Fe3O4 plus H2. Here it is 1, but here it is 4. So can I put here the number 4? Because I want to equalize oxygen. 4 into 1 becomes 4. Here it is 4. Now hydrogen is existing in the combined form with oxygen. So now 4 into 2 has become 8 for hydrogen. But here it is only 2. That means, can I just draw a tabular column for hydrogen next? And I want to make it equal. So what is that number that I have to multiply on the product side? It is 4. So I have to write 4 besides hydrogen on the product side. Well, now oxygen has got balanced. Hydrogen has got balanced. Now only concern is for now balancing of iron. Now let us quickly draw the tabular column for iron. Let me write the equation once again. Fe plus 4H2O I have written gives Fe plus, here I have already written, Fe3O4 plus 4 hydrogen. Now here how many atoms of iron is seen on the product side? It is 3, but on the reactant side it was only 1. So how to make this 1 equal to 3? Obviously we have to multiply this side by 3. Now this 3 has to be written here. That means now this equation 3Fe plus 4H2O gives Fe3O4 plus 4H2 is known as the balanced chemical equation of iron reacting with steam. Now I want you all to understand that iron is existing in the solid state, whereas water is existing in the gaseous state. It is getting converted into mixed oxide of iron which is called as ferroferric oxide, given by the formula Fe3O4 plus hydrogen existing in the gaseous state. That means all these are telling us the existence of the physical state of reactants and products. Any particular equation, if we have to have it very perfectly represented, it is a must to denote the state of the substance which is reacting. So, iron is existing in the solid state. It is reacting with steam, thereby getting converted into iron oxide, which is specifically to be mentioned as mixed oxide of iron plus hydrogen. Truly speaking, this Fe3O4 is a combination of, let me tell you, Fe3O4 is actually a combination of FeO plus Fe2O3. That is why the formula comes as Fe3O4. You can see here, the formula is Fe3O4. So it is known as ferroferric oxide. Now, to the next 1 mark question. Write the balanced equation for burning of magnesium wire. Now, what is the symbol for magnesium? It is Mg. Burning is given, that means it is coming in contact with oxygen, which is represented in the molecular formula O2. That gives the product which is known as magnesium oxide. This is actually found in the form of white ash. Now let me show you this activity of burning of magnesium. Magnesium ribbon is well holded by means of a tongs, and it is burnt by a burner, Bunsen burner. Immediately magnesium wire gets burnt and it gets converted into magnesium oxide, white ashes of magnesium oxide. This particular balanced equation, if you just come across, especially during the fireworks time, magnesium is very much utilized in all your fireworks. So this balanced equation significance I want to highlight here. It is widely used in fireworks. So now very quickly we have to balance. This is a skeletal equation. Now how many atoms of magnesium is here on the reactant side? Let me write. We have elements, then we have LHS, then we have RHS. Elements are magnesium and then oxygen. Now magnesium is 1 on the reactant side, on the product side it is 1. But on the for the case of oxygen we have 2 here, here we have only 1. So how should I make this 2 equal to 1 into X? What is this number? X. So this X has to be 2. That means this 2 has to be written here. Once I write here 2, that means 1 into 2 becomes equal to 2. Once I write here 2, then this becomes 2 magnesium. That means here I have to write 2. So here I am going to multiply by 2 for magnesium, and on the product side again 2. That means this equation is only referred as balanced equation. 2 Mg plus O2 gives 2 MgO. Now to the next. Write the balanced equation for reaction of sodium with water. Now let's see. Sodium is highly reactive metal, alkali metal which reacts with water. It bursts out in flames, giving sodium hydroxide, and hydrogen gas is liberated. So the equation will be Na reacting with H2O to form NaOH plus H2. Now, quickly to balance the equation, adopt the hit and trial method and start balancing the equation. So when we generally start practicing lot of equations, so very quickly you can say 2Na plus 2H2O gives 2NaOH plus H2. This equation is known as a balanced equation. Very quickly you can check. Sodium is 2 now. On the reactant side, on the product side it is 2. 2 into 2 is 4. Here it is 2 plus 2, 4. Oxygen is 2 here. Here also it is 2. That means such an equation is called as balanced equation. Now, write the balanced equation of thermite process. Fe2O3, when it reacts with aluminium, it gives alumina plus iron. Is what is known as thermite process. Now, let us balance this equation. Fe2O3 plus Al gives Al2O3 plus Fe. Now, how many atoms of aluminium are here? 2. So, can I write here 2? Iron is 2. Can I write here 2? Now, what should be done in order to balance the equation? Tell me. If I write here 2, 2 into 2 becomes 4. Then here, can I write 4? 2 into 3 becomes 6. Can I write here 2? I am just adopting the hit and trial method. Let me write the equation here. I will just rub this. Fe2O3 plus Al gives Al2O3 plus Fe. Okay. So 2 into 2 becomes 4. Can I write here 4? Now 2 into 3 becomes 6. Can I write here 2? So 2 into 2 becomes 4. Can I write here 4 Al? That means it is a balanced equation. So you have to write the balanced equation as 2Fe2O3 plus 4 Al gives 2 Al2O3 plus 4 Fe. Now I want you to observe this reaction. The rails, when welding has to be carried out, they make use of this thermite process. The molten iron. The molten iron, you can see this particular video. If you see this particular railway track welding involves this molten iron to be getting evolved whenever iron oxide is made to react with aluminium. Now to the next reaction. It's a 1-mark question that has been asked in March 2020 preparatory exam. The values of X, Y and Z in the following balanced reaction respectively. This is lead nitrate on reacting gets converted into lead oxide plus nitrogen dioxide plus oxygen. What are the coefficients of the reactants and the products is asked. The options given are 242, 244, 2, 2, 4 and 4, 2, 2. So very quickly you have to write the equation. PbNO3 twice gives PbO plus NO2 plus O2. Adopt the hit and trial method. Nitrogen is 2 here. Here it is only 1. Yes. Now 2 PbNO3 twice gives 2 PbO plus 2 into 2 becomes 4. Can I write here 2? If I write here 2, I want to quickly notice 2 Pb, 2 Pb. Then N2 is 2, 2 into 2, 4. Here also it becomes only 2. That means I have to use a number here, 4. Nitrogen becomes 4. Oxygen, 3 into 2, 6. 6 into 2, 12. That means oxygen atoms are 12 in number. Here on the, this is on the left hand side and this is on the right hand side. I have to just quickly see. Oxygen is 2 plus 4 into 2 is 8 plus here it is 2. So 2 plus 8 is 10, 10 plus 2 is 12. So the correct answer is 2, 2, 4. That is the answer. So the answer is C. Now to the next question. It's a 2 marks question asked in the state level SLC preparatory exam of 2020, February 2020. Very recently that has got over. Balance the following chemical equations. HgS is given. It's an ore of mercury called as cinnabar. So mercuric sulfide ore has been made to undergo roasting, burning in excess of oxygen, resulting in the formation of mercuric oxide and sulfur dioxide. So let us quickly balance. HgS plus O2 gives HgO plus SO2. Now, can I write here 2? Can I write here 2? If I do that, mercury becomes 2, sulfur becomes 2. So, is it not necessary for me to put here 2? Then here it becomes 2 plus 2 into 2 is 4. 4 plus 2 is 6. So, can I not write here 3? So, this becomes the first balanced equation. Now, second equation. HgO, it is called mercuric oxide, gives mercury plus oxygen. Now quickly balance. Atoms of mercury are 1 on either side, but oxygen on the reactant side is 1. On the product side it is 2. So you have to write here 2 and then write here 2. So this is 2HgO gives 2Hg plus O2 is what is known as the balanced equation. This question will fetch you 1 mark and this question will fetch you 1 mark. Now coming to the next 2 mark question that was asked in 2019 exam. Red hot iron reacts with steam. So let me tell you, some time back we had seen this iron reacting with steam, H2O, giving mixed oxide of iron along with hydrogen. So did we balance few minutes back? 4H2O, then we wrote like this, and then 3Fe. 3Fe plus 4H2O gives Fe3O4 plus 4H2 is known as the balanced equation of the first subdivision, which will fetch you 1 mark. Now, magnesium, Mg, reacts with dilute hydrochloric acid. It is HCl. It gives magnesium chloride, MgCl2 plus hydrogen. You have to balance, then only you will get your 1 mark. Now this equation is not balanced, so you have to put the number 2. So Mg plus 2HCl gives MgCl2 plus hydrogen is the balanced equation. So let me summarize. In today's session, we have seen the law of conservation of mass, which mainly governs all your chemical equations balancing, which states that matter can neither be created nor be destroyed. In other words, we can say mass can neither be created nor be destroyed, and ensure that always there are equal number of atoms on the reactant side as equal to the number of atoms on the product side. All the equations have to be balanced, only then you're sure to get your centum score in chemistry. So in today's class, we have seen some of the equations as self-balanced equations. The equations balanced on its own. But some equations we have tried balancing based upon the method which is just called hit and trial method. So you have to keep trying with various numbers and see that the number of atoms on the reactant side is always equal to the number of atoms on the product side. This particular law was stated by the great scientist called Anthony Lavoisier. Well, hope to see you in the next session where different types of chemical reactions will be covered. Thank you.